having indices. Indices in mathematics. Indices. Indices. Now, indices is a topic that if you're in primary school, you should know. If you're in the junior secondary, you should know. Even in the senior secondary, you should know. Even it's also in further maths. So indices. But we're going to deal with the basic, all right? Today, we'll start from the rules of indices and then we keep working. So let's start. By the way, indices is the plural word for the word index. Indices is the plural word for the word index. Indices talked about power. When you say 2 raised to power 3, that's like 2 with 3 index, okay? 3 as the index. So you might be asked a question to express this 2 times 2 times 2 times 3 in index form. What they are telling you is to express this in power, index. So this becomes 2 raised to power 3, then times 3. Because 2 times 2 times 2 is 2 raised to power 3. That's like 2 raised to power 2 means 2 times 2. Alright? And 2 raised to power 5 means 2 times 2 times 2 times 2 times 2. Of course, there's a special name for raised to power 2. Raised to power 2, we call that square. And raised to power 3, for example, 2 raised to power 3, we call it cube. Alright? So now let's see, what are these basic laws of indices that will help you to solve problems on indices? Let's see these laws of indices, the laws or the rules. Alright? So number 1, the first one says, if you have any number, by the way, we've done algebra, so when you see letters, you understand that we're talking about numbers. These are variables that actually represent certain values, which we are calculating for. So in this case, if you see a number, let's just call it x. If you multiply the same base, you add, okay. So if you have x now, raised to power or a, alright, times x raised to power b. So this law says when you have two numbers having the same base and you have multiplication, you have to multiply them, that what you do is just to add their powers, you add the index. So this and this, you can see the same. This is different if you have x, okay, an example. If you have 2 raised to power 5 times 2 raised to power 3, that anytime you have something like this, this is 2, this is 2. What you will do is just to add their powers. That is when multiplication is involved. It's not the same thing as 2 raised to power 5 plus 2 raised to power 3. You now say, okay, because the base are the same. Are we missing this thing? Larynx, yes, we are having maths. So we have 2 raised to power 5 plus 2 raised to power 3. You won't say, okay, the rule says when we have this that we add the power. No, this is different from this one. The rule says when you have a multiplication of two numbers and the bases are the same, alright? The bases are the same. What you do, this is called the base and this is called the power on the index. So what you do is to add up the powers, alright? So x raised to power a now times x raised to power b will give us what? Will give us x raised to power what? A plus b. So x raised to power a times x raised to power b will give us x raised to power a plus b. That's the rule. So 3 raised to power 5 times 3 raised to power 2 will give us 3 raised to power 5 plus 2, which is 7. Let me explain. So 3 raised to power 5 times 3 raised to power 2. 3 raised to power 5, I told us earlier on already. So 3 raised to power 5 is 3 times 3 times 3 times 3 times 3. That's 3 raised to power 5. Now, times 3 raised to power 2, which is 3 times 3. So we have 1, 2, 3, 4, 5, 6, 7. So that's 3 raised to power 7. So you see where the rule comes in. That when you have two numbers multiplying each other, the same base, what you do is to what? Add their powers. So this will give, this time around, if you're having division, now this is multiplication. So what if you are having division? You're having x raised to power a divided by x raised to power b. The same base, the same base, you can see. But this time around you're having division. What will happen? You're going to subtract the power. So you're going to have x raised to the power a minus b. Let's see how that works. So let's say you have 3 raised to the power 3 divided by 3 raised to the power 2. So by using the law, I will know that my answer here will be what? 3 raised to the power 3 minus 2, which is 3 raised to the power 1. If we divide, we subtract. If we divide, we subtract the power. If we divide, we subtract the powers division. Yes, must be the same. So 3 raised to the power 3 divided by 3 raised to the power 2 will give us 3 raised to the power 3 minus 2, which is what? 3 raised to the power 1. Anything, okay, we're coming to that. Anything raised to the power 1 is that same thing. So let's see. So 3 raised to the power 3 means 3 times 3 times 3 divided. That's all over. 3 raised to the power 2 is 3 times 3. So 3 cancel 3, 3 cancel 3. So we have just one 3, which is the same thing as 3 raised to the power 1. Anything raised to the power 1 is itself. If the base is different, what will happen? You cannot do anything. You cannot. There's 3x raised to the power a times y raised to the power b. You are going to have x raised to the power a, y raised to the power b. You cannot, this is what you have, okay? This is what you're going to have. It's just like say x times y. You're going to have xy, okay? Note that. So rule number 3 now says, rule number 3 says, any number, 50, 20, 100, thank you AMT, 1000, 1 million, any number represented by x here, raised to the power of 0 will give us what? 1. So 50 raised to the power 0 is what? 1. 1 million raised to the power 0 is what? 1. 10,000 raised to the power 0 is what? 1. That's rule number 3. So rule number 4. Please, if you are writing, you need to write fast, alright? So I can wipe this off. Can I wipe this off now? Thank you, AMT. Thank you. Apart from 0 to the power of 0. 0 to the power of 0. 0 to the power of 0. Yes, okay. It's undefined, okay? Can I wipe up this board now? Yes, okay. Number 4. So rule number 4 says, when you have a negative index, a negative power, so you have x raised to the power minus a, let's use a. So when you have a negative index, all right, what you are going to do is to reciprocate this raised to this power. So if you have 2 raised to the power, let me start with 1 first. Let me start with 1. So you have a negative index, like with 1, you're going to reciprocate this. This becomes 1 over x raised to the power of what? 1. So if this is 2, this will be raised to the power of 2. So if this is a, this will be raised to the power of a. That's this rule. That's what this rule is saying. So when you have the negative what? A negative power, this minus, this raised to the power of minus, because of this minus you are seeing here, it becomes 1 over. That's, you reciprocate this. Reciprocating means, if they ask you what's the reciprocal of 5, reciprocal of 5 is 1 over 5, alright? Like you're turning it upside down. Don't forget that 5 is the same thing as 5 over 1. So the reciprocal of 5 over 1 is 1 over 5. The reciprocal of 2 over 3 will be 3 over 2. So you have to reciprocate this now, and whatever you have here becomes the power, okay? Reciprocal means 1 over. Yes. So number 5. Now rule number 5 says, when you have a number with its power in brackets raised to the power of another one, say like b, that these powers multiply. This a multiplies b, and then you're going to have x raised to the power a times b, which is ab. Example, you have 2 raised to the power 2 in brackets raised to the power 3. Your answer will be 2 times 3. This 2 multiplies this 3, and you have 2 raised to the power 6. That's what that rule is saying. Alima says, come again. Alima, what don't you understand? Alima, what don't you understand? Everything. Okay, Alima, I'm just giving you the rules that guide indices. When it comes to indices, these are the laws that we work with, okay? Pato says this one is simple, okay? These are the laws that we work with, all right, in indices. You need to know these things, all right, before you can solve problems. You've not even started solving problems. I'm only giving you the laws that you are going to work with. You need to know these things. You should know that when you have a number raised to a power times another number raised to its own power, as long as these two numbers are the same, and I give an example, what you will do is that you'll be adding the powers. Alright, so you have A plus B. That's what it says. That's what this rule says. So if you have 3 raised to power 2 times 3 raised to power 3, your answer will be what? 3 raised to power 2 plus 3, 5. That's the answer. That's what that rule says. Now, the other second rule says if this were to be division, then your answer will be x raised to power, you subtract this, A minus B. Alright, so this becomes A minus B. Yeah, thank you. Okay. So now the third one, what was the third one? The third one says any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. And then the fourth one says when you have a number like this raised to the power to a negative power, that because you are having this, you are going to reciprocate this, it becomes 1 over. Alright? It becomes 1 over. You turn it. But what if this were to be a fraction? What if this were to be 2 over 3 raised to power minus 3? 2 over 3 raised to power minus 3. 2 over 3 raised to power minus 3. I said because of this negative power, yeah, you are going to reciprocate this. This 2 over 3 becomes what? 3 over 2. Then raised to this power, which is raised to power 3. So it becomes 3 over 2 raised to power 3. But if it's just a single number like 2 raised to power minus 3, you are going to reciprocate 2 also. Now don't forget that 2 is the same thing as 2 over 1. Alright? So 2 over 1 becomes what? 1 over 2. So you're going to have 1 over 2, then raised to power what? 3. So that's what that rule is saying, rule number 4. Then rule number 5, this one now. Rule number 5 says when you have a number raised to any power in a bracket raised to another power, that those two powers will multiply each other. For example, 2 raised to power 5, bracket close, raised to the power of 3. Now this power 5 will multiply this power 3. And 5 times 3 is what? 15. So you are going to have 2 raised to power what? 15. I hope we are following. So let's continue. Now the next law. Law number 6. Law number 6 says when you have a fraction, when you have in your power plate, you have a fraction. For example, x raised to power a over b. Okay, let me. Can I wipe this off? I hope I can wipe this off. Welcome, Evelyn. Welcome. Yes, we do. Okay. Great, Nitina. Good to know. Can I wipe this off? Yes. So number 6 says, if you have a number raised to the power of a fraction. If you have a number, any number, I say again, this x represents numbers, okay? So, if you have a number raised to the power of fraction. Hello, Blacko, welcome. So, raised to the power of a fraction, say raised to power a over b. Example, like 3 raised to power 1 over 2. Or like 5 raised to power 2 over 3. These are examples, like example, something like this one. When you have any number raised to the power of a fraction, what will be applied here? What will happen here? The rule says that when you have a number raised to the power of a fraction, that for this fraction, this denominator, the number down becomes the root, whereas the number up becomes the power. What does that mean? This means you are going to have b root of x raised to the power of a. So the number down, we have a over b. Don't forget, let me write it this way. So the number down will become the root of this. So if the number down were to be 2, you are going to be getting the square root. If it is 3, you are going to be getting the cube root. If it's 4, you're going to be getting the fourth root. Alright? So whatever number you have down becomes the root, and whatever number you have up becomes the power. Thank you, Virgin Boy. Thank you for the roses. Thank you. So you're going to have b root of x raised to the power of the numerator, the number up. So the number up becomes power, and the number down becomes root. Are we following? So now use this as an example. 3 raised to the power of 1 over 2. So 2 becomes the root here, and 1 becomes the power. So this will give us the square root, 2 root, that's square root, alright? We don't write 2. So that's square root of 3 raised to the power of 1. That's what this becomes. What about this one? This one will become, we have 3 down here, so we have 3 roots, which is what? Cube root. So the cube root of 5, put my 3, the cube root of 5 raised to the power of 2. That's what this becomes. Are we following? I need to know that we're following. Are we following? If you're following, can I see thumbs up? Can I see thumbs up? If you're following, I want to see thumbs up. So are we following? Nitina says come again. Okay. Another example. Okay. So another example. So if you have 16 raised to power 1 over 2, or raised to power 3 over 2, for example, 16 raised to the power of 3 over 2. The number down becomes the root, the number up becomes the power. Alright? The number down becomes the root, the number up becomes the power. So this becomes 2 root of 16, which we call square root. Okay? So that's square root of 16 raised to power 3. Yes, it's square root. So it becomes square root of 16 raised to the power of what? 3. So what is the square root of 16? The square root of 16. What's the square root of 16? The number that multiplies itself to give us 16. 4. So that's 4. Because 4 times 4 will give us 16. The square, okay. Square root of 16 is 4. Now 4 raised to the power 3. 4 raised to the power 3 means 4 times 4 times 4. 4 times 4, 16. 16 times 4 is what? 64. Alright? So that's 64. That's the answer to that one. So who was asking for another example? Do you understand this now? Do you understand? That's what this rule is saying. Alright? It says that when you have a number, any number raised to the power of a fraction, that the denominator becomes what? Root, and the numerator becomes what? A power. So it will now be equal to the big root of x raised to the power of a. That's this rule. That's this rule. Yes, okay, good. Now number 7. So rule number 7 says, okay, I think that's all. Okay, let me just give it. So rule number 7 says, if you have something like x raised to the power of a and y raised to the power of b, now all in brackets raised to the power of c, that this power is not affecting this alone, it's affecting everything. Okay, so this a is going to multiply c and b is going to, just like your normal algebra now, a plus b bracket plus c, c will multiply everything. So this is c times a times c becomes ac, and this becomes bc. So the same thing happens here. All right, so you are going to have x AC, Y, B, C. That's this one. Alright, so it's not affecting just the B alone, it's going to affect the A also. Now, these are the rules. If you've understood so far, can I see? If you have questions, you don't understand, alright? Can I see in the comment section if there's something you are missing? I want us to deal with this so that we can now go on to solving some problems. Let me see those that do not understand yet. You have one question or the other. You want to ask a question too. Do now. Let's go. Understood. Good to know. I don't understand it. Vicky Ella, what don't you understand? Which one? Please repeat 7. This one. Okay. I'm going to repeat this one. So this one says, okay, let me give an example of this one. An example of this one is when you have 2 raised to the power 5, y raised to 2 raised to the power 5, x raised to the power 3, into bracket raised to the power 2. Alright, so what happens? That this raised to the power 2 is not affecting this alone, or it's not affecting this alone. It will affect both of them. Okay, so this will become 2 raised to the power 5 squared. And that's 5 times 2 becomes 2 raised to the power 10, and what x raised to the power 3 times 2, x raised to the power 6. That's what this one is saying. That's what this rule is saying. Repeat number 6. Okay. Number 6 says, so number 6 says, whenever you have a number raised to the power of a fraction, alright? A fraction, when you see a number over another number, that's what we call a fraction. Okay, so when you see any number raised to the power of a fraction, what happens is that the denominator in your fraction becomes the root of this number, then raised to the power of whatever you have up here. So the number up becomes power, the number down becomes root. So the number up is power, the number down is root. 25 raised to the power of 2 over, okay. 125 raised to the power of 2 over 3. 125 raised to the power of 2 over 3. 125 raised to the power of 2 over 3. What are we going to do? This becomes root and that's power. So we are going to have the 3 roots of 125. That's the cube root. So cube root of 125, because we have 3 here. If this were to be 4, it will become the 4th root. If this were to be 5, the 5th root. If it is 2, it's the square root. So because we are having 3, we are going to get the cube root of 125 raised to the power what we have up there, raised to the power 2. So what is the cube root of 125? What number times itself will give us 125. That's 5. So 5 times 5, 25. 25 times 5, 125. So we're going to have 5. That's the cube root of 125. Now raised to the power 2. So raised to the power 2. 5 raised to the power 2 is what? 25. Which means 5 times 5. That's the answer. So that's rule number 6. That's rule number 6. Alright, so now we're going to go on to solve questions on indices. Some questions on indices. Indices problems. So examples, some examples. Number 1, we have number 1 says, okay, simplify. By the way, these are exam questions. So simplify 27 raised to the power of 1 over 3, all in brackets, raised to the power of 2. So we're asked to simplify this. Keep it up. Thank you, Cyberchick. So we're asked to what? Simplify this. 27 raised to the power of 1 over 3, all raised to the power of 2. We're asked to simplify this. Okay. Remember the rule again that says when you have any number raised to the power of a fraction, a over b, that the number down, the denominator becomes root and the number up becomes power. So solving what is in the bracket, 27 raised to the power of 1 over 3. Let me write it out clearly. So the 3 which is down becomes what? Root. So that's cube root, alright? So raised to the power of 1. So we're going to have solution. So we're going to have the cube root of 27 raised to the power of 1. Raised to the power of 1. Anything raised to the power of 1 will give you that same number, right? 25 raised to the power of 1 is 25. 2 raised to the power of 1 is 2. 10 raised to the power of 1 is 10. Anything raised to the power of 1 will give you that same number. So 27, cube root, 3. So cube root of 27 raised to the power of 1. That's what we have here. Then raised to the power of what? 2. Oh, don't forget. So rule 7 is also applicable here. Rule 7, is it rule 7 now, or rule 3 or rule 4? That says when you have x raised to the power of a outside b, now what happens? That this multiplies this. That this multiplies this. So you have a times b, and then you have x raised to the power of what? ab. So that was supposed to be done before we even do this. So we're supposed to do 1 over 3 times 2, alright? So 1 over 3 times 2, what will it give us? 1 over 3 times 2. 2 times 1 will give us 2 over 3, alright? So that's what it's going to give us. So we're going to have 27 raised to the power of what? 2 over 3. And now we can continue. Yeah, exactly, okay? Is Becky here? Hello, Becky. So are we following? Are we following? Are we following? Do we understand what I did here? Do we understand what I did here? Do we understand? Do we understand? No. No. The rule says, what rule was that again? Rule number 5. Rule number 5 says x raised to the power of a or raised to the power of b. What will happen? Let me ask us if you've been following. What will happen when you have this? What is supposed to happen here? Thank you. You multiply a by b. That's what the rule says. So this becomes what? That you multiply what is in the bracket, the power in the bracket, by the power outside the bracket. Yeah, we're following. Okay. So this becomes what? X raised to the power of what? AB. So that's what you're supposed to apply here. So we're going to have rule number 3 first, and then rule number, what now? Number 6. Yeah. I'm great, Becky. Welcome. Thanks for joining me tonight. Multiply A times BAB. Yes, Nick, that's what we did here. So we multiplied 1 over 3 by 2, and this is it here. So 1 over 3 times 2 will give us what? 1 times 2, 2 all over 3. And this is it here. So 2 over 3. Alright? So now the next thing for us is to solve this, simplify this. We said whenever you have a fraction as index, what happens? The number down becomes the root, alright, raised to the power of this. So it becomes 3 root, which is what we have here, 3 root, which is cube root of 27 raised to the power of 2. So we have the cube root of 27 raised to the power of 2. Are we following? And by the way, if you had even done the same, solve this one in the brackets first, then raised to the power of 2, you're going to get the same thing back. Answer is 9. Okay. So what is the cube root of 27? 3. So raised to the power of 2. 3 raised to the power of 2 is what? 9. That's it. So the answer is 9. Do we understand this? Do you understand this? Three power of 2 is 3 times 3. Yes, yes. Solomon says no. Please come again. Okay. No. Yes, yes. Okay. The rule says, alright, you multiply this by this, alright? Or you choose to solve what is in the bracket first, and then this becomes the root. Let me solve it again. Please pay attention. Solution. So we have 27 raised to the power of 1 over 3, all raised to the power of 2. This multiplies this. Why? The rule says x raised to the power a raised to the power of b, that a will multiply b. Remember, So you're going to have x raised to the power of what? A times b will give us AB. Right? So we applied that here. So 1 over 3 times 2 will give us what? 1 times 2 all over 3. That's 2 over 3. So now this will give us what? 27 raised to the power of 2 over 3. This multiplied by this gave us the 2 over 3 here. So now what is the next thing? We simplify this one. Knowing that when you have any number raised to the power of a fraction, the denominator becomes the root and the numerator becomes the power. Are we following? Achievement, thank you for the rules. So what happens next is that we have a cube root of 27 raised to the power of 2. Cube root of 27 raised to the power of 2. We have a cube root equal to the cube root of 27 raised to the power of 2. The 3 becomes cube root, alright? The 2 becomes the power. So cube root of 27 means what number multiplied by itself again will give us 27. Okay, how you get? So what number is that? That is 3. Because 3 times 3 is 9. Then times another 3, that's 27. So the cube root of 27 is what? Is 3. So 3 now square. 3 raised to the power of 2. 3 raised to the power of 2 means 3 times 3. And it's going to give us what? 9. C'est fini. That's our answer. That's our answer. So that's how we got that. Now let's move on. Number 2. So question number 2 says, question number 2, simplify 36 raised to the power of 1 over 2 times 64 raised to the power of minus 1 over 2 times 5 raised to the power of 0. 36 raised to the power of 1 over 2 times 64 raised to the power of minus 1 over 2 times 5 raised to the power of 0. So what? Let's solve the solution. Alright, so 36 raised to the power of 1 over 2 times 64 raised to the power of minus 1 over 2 times 5 raised to the power of 0. So what we want to do here, we want to express this. By the way, any number raised to the power of 0 is what? 1. Any number raised to the power of 0 is 1. So the rule says that any number raised to the power of a fraction, what happens? The number down in the fraction becomes the root and the number up becomes power. The number down becomes the root and the number up becomes power. And by the way, we have a negative power here. And remember, when you have the negative power, you reciprocate this. So 64 becomes 1 over 64. So we're going to have this now. 36 raised to the power 1 over 2 becomes the 2 root of 36, which is square root of 36, raised to the power of the 1 up, which is 1. And anything raised to the power 1 remains that same thing. So this now is this. The next thing we have is times 64 raised to the power of minus 1 over 2. Now, because it's a negative power, alright, minus, you reciprocate this. So what is this going to become? It will become 1 over 64. But don't forget, you have 1 over 2, fraction. So this is double rule applicable here. The negative rule and the power fraction power rule. So the negative rule says you reciprocate this 1 over 64. And then the fraction says the number down becomes your root and the number up becomes your what? Power. And the number down here we have 2. So the square root of this. Are we following? So the square root of this. The square root of this raised to the power of what? 1. Anything raised to the power 1, I don't even need to put 1 there. Because anything raised to the power 1 will give us that same thing. Then the next term we have here is times 5 raised to the power of 0. It says any number raised to the power of 0 will give us what? 1. 1 million raised to the power of 0 is 1. Yeah, thank you. So 5 raised to the power of 0 is what? 1. So times 1. The next step. What is the square root of 36? What is the square root of 36? What's the square root of 36? 6 over 8 is your answer, IDK. Okay, let's see. IDK says 6. Okay, good. 6. So 6 times. Now, what is the square root of 1 over 64? What is the square root of 1? Lemma 6. Okay, good. What is the square root of 1? 1. Thank you, Ajwa. Then what's the square root of 64? What's the square root of 64? Please, if you've not shared this live, do well to share this live so others can join in and keep power tapping and like up the stream. What's the square root of 64? 8. Good. So, square root of 1 is 1 and the square root of 64 is 8. So, the 6 times 1 over 8 times 1. So, now we need to solve. This is like multiplication of fraction. Yeah. 6 times 1 over 8 times 1. Thank you, Rashid, for the roses. Thank you. Or for the rows. So, 6 times 1 over 8 times 1. You want to cut by common factor or you just want to multiply straight and at the end of the day, you divide by common factor. 6 times 1, 6. 6 times 1, 6 times 1 is 6, right? That's 6 times another 1 is 6. So over 8. So we have 6 over 8. So this is 6 over 8. Now you want to check this too. You see there is a common factor. So we're not going to leave our answer at 6 over 8. There's a common factor. The common factor of 2. 2 can divide 6, 2 can divide 8. And so we'll divide by 2, which is 3, and divide by 2, which is 4. So we have 3 over 4. Is there another thing that can be done here? Can we break this down? No. This is the what? The simplest term, the lowest term. And it's a proper fraction. So that's our answer. 3 over 4. That's it. Yeah, 0.75. Decimal, if you want to express in decimal. So 3 over 4. I hope we're following. Good, 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 good. Are we getting this? Young G, thank you for the rules. Are we getting it? Are we getting it? Lively Queen. Okay. So number 3. I believe I can wipe it off. Number 3. Question number 3 says, simplify, another one. Simplify 9 raised to the power of minus 1 over 2 all over 27 raised to the power of 2 over 3. Simplify 9 raised to the power of minus 1 over 2. Why do you leave 2 aside on the square root of 36? Why did I leave 2 aside? Nitina, no, the 2 was what generated the root. It was raised to the power of 1. 9 raised to the power of minus 1 over 2 over 27 raised to the power of 2 over 3. Network is stopping now. 9 raised to the power of minus 1 over 2 over 27 raised to the power of 3. 2 over 3. So the same thing applies. Okay, I want us to work this out. Let's work this out quickly. Let's get our answers. Let's see if we understand this already. Work it out, work it out, work it out. Let's see our answers. Let's see our answers. 9 raised to the power of minus 1 over 2 over 27 raised to the power of 2 over 3. You're applying the same rules, okay? What will it give you? What will it give you? Kayode said 3, okay? Michael said 1 over 3. AMT, is it the answer? Okay? I'm waiting for others. Alima says 1 over 3. Okay, so we have two answers now. We have 3, we have 1 over 3. Abidaniel says 3 raised to the power of 1. Abidaniel, if that is your answer, then that's the same thing as 3 because 3 raised to the power 1 is 3. Anything raised to the power 1 is that same thing. 3 raised to the power 1 means just 3. Alright? 3 raised to the power 2 means 3 multiplied 2 times. 3 raised to the power 3 means 3 multiplied 3 times. So that's 3 raised to the power 1 just 3. 1 over 3, IDK 3, Solomon says 1 over 3. Kickstart said the answer is 3. 1 over 27. Empty. Sweet Larry, 1 over 27 also. So okay, let's see. So 9 raised to the power of minus 1 over 2 all over 27 raised to the power of 2 over 3. Now let's start with this one. Let's start with this one. So solution. 9 raised to the power minus 1 over 2, negative, and a fraction. We have negative fraction. So we have the negative rule applicable and the fraction rule also applicable. Thank you, Destiny TikTok. Thank you for the roses. The negative rule applicable and the fraction rule also applicable. So the negative rule says what? We reciprocate this. So 9 becomes what? 1 over 9, right? 1 over 9. Then the power up here, the 2 down becomes the root. So raised to the power of 1, 2 roots, which is square root. So square root of this, raised to the power 1. So you have the square root of this. So this whole thing now, 9 raised to the power of minus 1 over 2 is this. It's the square root of 1 over 9. The square, in fact, no, it's the square root of this. The square root of 1 over this. Alright, so this is. Then all over, divided, all over, let me just put it here first. So all over, by the way, that's divided. I could just take and just write my divided. Okay, let's leave it there. So all over 27 raised to the power of 2 over 3. Now there's no negative here, so we're not reciprocating anything here. We just apply this. The 3 root of 27 raised to the power of 2. 3 roots. The number down becomes the root. Why do you leave 2 aside? Nitina again, I said when you have the denominator like this in a fraction, which is the power, the denominator becomes the root. I explained it before. So 2 here becomes the square root, alright? So the same thing applies here. Now you're having 3 here, you're not having 2 here. So this 3 now becomes the root of this one, right? Which is the cube root of 27. Right? It becomes the cube root of 27. Thank you, MT, thank you. So this becomes the cube root of 27 squared raised to the power of 2. So 1 over root 9 all over the cube root of 27 over 2. Alright, so let's deal with this now. What is root 9? Hello, good evening. Good evening, Matthew. Welcome. Please, what time do you start teaching? When will you? We have our classes Mondays, Wednesdays, and Fridays, 8 p.m. 8 till 10. So what is root 9? That's West African time, Nigerian time. What is root 9 is 3. Root 9 is 3. So this will give us 1 over 3, alright? So you have equal to 1 over 3 divided by, what is the cube root of 27? The cube root of 27 is 3. 3 raised to the power of 2, alright? 3 raised to the power of 2 is 9. Thank you, Matthew. Matthew Taiwo, thank you for the rules. Cube root of 27 is 3. 3 raised to the power of 2, that's 9. So we have 1 over 3 divided by 9. So let me write it out. 1 over 3 divided by 9. Of course, when we are solving division of fraction, what happens? You change your division to what? Multiplication, and then you reciprocate the one on the right. So this will become 1 over 3 times, and this 9 becomes what? 1 over 9. So what happens? 1 times 1 equals 1 over 3 times 9 becomes 27. And that's our final answer, 1 over 27. 1 over 27. That's the answer. Yes, the empty, so you got it. Who else got it? I saw someone else. So if you got 1 over 27, well done. That's it. And he says, I don't understand. Okay, I'm going to go back. I'll explain. IDK, what did you get? What was your answer? Sweet Larry, yes. Sweet Larry, I saw yours. You got it. Alima, you did not get it. Let me explain again. So we have 9 raised to the power of minus 1 over 2 all over 27. Oh, Larex, I don't understand. Okay, I'm explaining again. I got 1 over 20, freshman. Uh-oh. Okay, let's listen. So 9 raised to the power of minus 1 over 2. Alright, remember the rule. The rule says x raised to the power of what? Minus a. That this minus will make this to be reciprocated. Alright, becomes 1 over x. If it's just minus 1, it becomes 1 over x raised to the power of 1. If it's minus a, it becomes 1 over x raised to the power of a. Are you following? If it's minus 5, it becomes 1 over x raised to the power of 5. That's what the rule said. So we are working with that rule. When we have this, let me write it out. Let me bring it out. So you have 9 raised to the power of minus 1 over 2. So because of this minus, this 9 becomes 1 over 9. So now, raised to the power of 1 over 2. Again, the rule says if you have x raised to the power of a over b, that what you have here, the b, becomes the root of x raised to this power of a. So you are going to have the b root, of x raised to the power of a. So this becomes the root of this raised to the power of whatever you have up there. So that's what we use in solving this. So this negative already, because of this negative power, we already have this 1 over. Then 1 over 2 now becomes this 2. Just like this b became the root of x. This 2 which is down also becomes the root of 9. And so we're going to have the root of 9. Then this a, which is raised to the power here, a. So this 1 will become raised to the power of 1 here. And I don't even need to put 1. Anything raised to the power 1 will give you that same thing. Alright? So this whole thing, 9 raised to the power of minus 1 over 2, is simplified to this. 1 over the square root of 9. I hope we're getting that. So, now this one, let me write this out also. 27 raised to the power of 2 over 3. The same thing applies. The same thing applies. The number down becomes the root of this and this raised to the power. So it becomes the 3 roots, which we will call cube root of 27, raised to the power of the 1 up, which is 2. So what is the cube root of 27? It's 3. So 3 raised to the power of 2. 3 raised to the power. Am I too fast? Larex. So 3 raised to the power of 2 will give you 3 times 3, which is what? 9. Why did you leave 1 outside? Why did I leave 1 outside the root? Aisha, which one? Which one? Is it this one? Okay, go back again to the rule. Because the rule says x raised to the power of minus a will give you what? 1 over x raised to the power of a. Alright? So this negative power here will cause you to reciprocate the number, which is 1 over x, and then raised to the power of whatever here. Alright? So it is this here, this whatever you have here, that will be raised to the power of whatever you have here. If this becomes a fraction, it is this raised to the power of fraction, not this. This one is just 1 over. Alright? So in case you now have something like minus a over b, like this first one now, a raised to the power minus a over b, it will become what? 1 over, because of this negative, 1 over x raised to the power of a over b. That's what this will become. So it is 1 over x, then x raised to the power of what? A over b. Now, x raised to the power of a over, this is not x whole number. This is x raised to the power of a over b. X raised to the power of a over b. Alright? So now this b becomes the root of x raised to the power of this a. So this b becomes the root of x raised to the power of this a. This b down here becomes the root of x raised to the power of this a. So you're going to have the b root of x becomes 1 over the b root of x raised to the power of a. So this is what you're going to have. Vikiela, why are you not following? So you're going to have 1 over the b root of x raised. So that's what this thing is going to give us at the end of the day. For the second one, we did u square of. But the second one we use 12. Which second one? This one? Giela, relax your mind. Yes, over Giela, you need to. This one, 27 raised to the power of 2 over 3. 27 raised to the power. 20 raised to the power of 2 over 3. This becomes the 3 root of 27 raised to the power of 2. So that's what this will be. 3 root of 27, that's cube root of 27 raised to the power of 2. There is no negative here. If this were to be negative, yeah, minus, you're going to have 1 over. Now let's continue. Okay. So I believe without that explanation, we should be able to get it now. So we have 9 raised to the power of minus 1 over 2. 9 raised to the power of minus 1 over 2. So we're going to have what? Act like you're not seeing the minus. Alright? So let's just say we're having 9 raised to the power 1 over 2. So this 2 becomes the root, alright, raised to the power 1. So 2 root of 9, which is square root of 9, over 1. I mean raised to the power of 1. Alright? So the square root of 9 raised to the power of 1. And I said I don't need to write the raised to the power 1 because anything raised to the power 1 will give me that same number. Alright? So now 1 over, right? Because of this negative, becomes 1 over. This negative makes it to be 1 over. Alright? If that will make you understand. So this negative here, when you just see negative, you just take it as what? 1 over. Except it's a fraction. So if it's a fraction like 2 over 3, assuming this number now is 2 over 3, raised to the power of minus 1 over 2. So again, neglect this negative and just do what you're supposed to do here. This 2 becomes the root of this. It becomes the root of 2 over 3 raised to the power of 1. And I don't need to put my 1. Now, then I can remember the negative. The negative makes this to be what? And by the way, this is a fraction. So 1 over 2 over 3. Okay, 1 over 2 over 3 will give me 3 over 2. So what you will just do is to flip this over. When you have a fraction, alright, when you have a fraction like this, raised to the power of negative, what you want to do is just to flip it over. It becomes what? 3 over 2. 1 of 64 power minus 1 over 2. Is that one here? If it's not here, we're not working on that. So do we understand this? Actually, 1 over 64. Okay, was it the one we did before? 64 power 1 over 2. So 64 raised to the power of minus 1 over 2. So what are we doing here? The 2 becomes the what? The root, right? So it becomes the square root of 64 raised to the power of this one here, 1. I don't need to put the 1 because anything raised to the power 1 will give me that same thing. Now because I have 1 here, that's it. 1 over 64, root 64, that's it. Okay, I understand now, Aisha, I understand. So this is what you're supposed to have. So this will now give you what? 1 over 8. Just solve and let's move to the next question. Okay. So Aisha, I hope I've explained that. So now, solution. Again, I'm explaining. 9 raised to the power of minus 1 over 2 all over 27 raised to the power of 2 over 3. So this will give us the 2 root of 9, which is the square root of 9, raised to the power of 1, which I don't need to include. Now, because it's negative, I have 1 over, alright? So divided all over by this, which is the 3 root of 27, which is the cube root of 27 raised to the power of 2. So the cube root of 27 raised to the power of 2. So this is what I have here. 1 over root 9 divided by cube root of 27 squared. Okay, so what is root 9? Root 9 is 3. So I have 1 over 3 divided, let me just put it there, divided by the cube root of 27, which is 3 squared, which is 9. Am I making a mistake here? One over divided. Okay, divided by what? Yeah, the cube root of 27 is 3. 3 squared, 9. Yeah, 9. Okay, so what are we going to do next? Division. becomes what? Multiplication. So you're going to have 1 over 3 times 1 over 9. Are we following? No mistake, okay, thank you. So 1 over 3 times 1 over 9. So that's going to give us 1 times 1 over 3 times 9, 27. That's the answer. Oladera, thank you. That's the answer. Have we gotten it now? So now let's move on to the next question. Question number 4. Question number 4. Question number 4 says, simplify 125 raised to the power of negative 1 over 3 times 49 raised to the power of negative 1 over 2 times 10 raised to the power of 0. I hope you can see this thing. So this is our question. Simplify 125 raised to the power of minus 1 over 3 times 49 raised to the power of minus 1 over 2 times 10 raised to the power of 0. Solution. So, someone should help us. What will happen to this? What will this become? 125 raised to the power of minus 1 over 3. What will it become? What will this become? Now, I'm not asking for the final answer. What will this become? I need someone. We are going to help ourselves here. Someone should help us here. Larex, what will this one become? Let's take it one after the other. 125 raised to the power of minus 1 over 3. Cube root of 125. Okay, Annie, good. Cube root of 125. Okay, because of the power, the denominator is 3. So what about the negative here? What happens to the negative here? 1 over 1225. So this is 125, not 1225. 125 raised to the power of minus 1 over 3. Okay, it's going to become, because of the negative, you're going to have what? 1 over. Alright, so let's leave that aside. Let's focus on the 1 over 3. So raised to the power of 1 over 3, this 3 becomes the what? The root of this. So cube root, we have 3. That's 3 roots, which is cube root. So cube root of what? Cube root of 125. Cube root of 125. So we have the cube root of 125 raised to the power of 1, which I don't need to write because it's going to give me that. Alright, so now I have negative power here, negative, so it's going to be 1 over. So 1 over the cube root of 125. So that's what this is giving me. 125 raised to the power of minus 1 over 3 is giving me 1 over cube root of 125. Alright, now this one. 45 raised to the power of minus 1 over 2. What is it going to give? 49 raised to the power of minus 1 over 2. What is it going to give? 1 over the square root of 49. Oladayo. One square root of 49. 0 is the answer. So, okay, we're going to have times 49 raised to the power of minus 1 over 2. This 2 here becomes what? Root. Alright? Root raised to the power 1. So, raised to the square root of 49. Now, negative, that's 1 over. So, 1 over the cube root of 125 times 1 over the square root of 49. Now, let's come to this third one. 10 raised to the power 0. Anything raised to the power 0 will give us what? 1. So 10 raised to the power 0 is 1. Right? Welcome, Agnes. So you have what? Times 1. So when you look at it this way, you are getting confused. Take it one after the other. Right? So now this is what we have. The next question. So what is cube root of 125? What is 125 cube root? Cube root of 125. What is the cube root of 125? The cube root of 125. 5. Good, thank you. So we have 5 as the cube root of 125. So this is 1 over 5 because we have 1 over the cube root of 125. So cube root of 125 is 5. So 1 over 5 times 1 over the square root of 49, 7, times 1. So 1 over 5 times 1 over 7 times 1. 1 times 1 times 1, 1 over 5 times 7, 35. And that's our answer, 1 over 35. So that's the answer to that question. So any question on this? Any question? Do we understand this now? Do we understand this? 1 over 36? Now solos, now 5 times 7 is 35. Larex is not hard, right? Yeah, okay, good. Yeah, good. Alright, let's move on. Number 5. Number 5. Question number 5 says, simplify 1 over 4 in bracket raised to the power of minus 1.5. So this is the question. Simplify 1 over 4 in brackets. Good to know you're getting it. Simplify 1 over 4 in brackets raised to the power of minus 1.5. Can we solve this one? 1 over 4 raised to the power of minus 1.5. Alima, what's the answer of this? First thing you want to do is to change this fraction to improper fraction, alright? That's the first thing you want to do. Change this. 1 over 1 over 2, you want to change it to an improper fraction. That will give you 2 times 1 is 2 plus 1, 3 over 2. So 1 over 1 over 2 will give you 3 over 2. That's the first thing. So solution. So 1 over 4 raised to the power of minus 1 whole number 1 over 2 will give you 1 over 4 raised to the power of minus 3 over 2. So how about at this level, what can we do? So what can we do now? Okay, don't forget your bracket, by the way. So what can we do? Okay, remove our bracket. How do we do that? What can we do? Inverse. Okay, why? Because we have a negative power. Who is that? IDK, okay? Because we have a negative power. That's 1 over. And because you have a fraction, 1 over 4. 1 over 1 over 4 will be 1 divided by 1 over 4. So you understand where the inverse came from. 1 divided by 1 over 4 will be 1 times 4 over 1. Alright? 1 times 4 over 1 will give us 4 over 1. So 1 over 4 raised to the power of negative becomes 4 over 1 reciprocated. Alright? So 4 over 1. Okay, so 4 over 1, which is the same thing as 4, right? I don't even need to put that 4 over 1. 4 over 1 is 4. So raised to the power of 3 over 2. So what's the next thing? What's the next thing? I don't even need to put this. What's the next thing? What's the next thing? What's the next thing? Okay, Flip. What is the next thing? Can you put this on YouTube? Yes, yes, yes. What's the next thing? Two raised to power 3. Can you know? Root 4, then cube it. Square root of 4 to the power of 2. The number down in the fraction becomes the root of this base, alright? Then raise to the power of the number up. So we have 2 here, becomes the root of 4. It has 2 root of 4, which is square root. Square root, no, we don't write 2, because this square root. So this becomes the root of this, alright? Of 4 raised to the power of 3. So that's what this becomes now. So 4 raised to the power of 3 over 2. 2 becomes the root here, alright? Raised to the power of what? 3. So what's the square root of 4? What's the square root of 4? 2, good. 2. So 2 raised to the power 3. So 2 raised to the power 3. And now what is 2 raised to the power 3? So what is 2 raised to the power 3? Yeah, regarding what is 2 raised to the power 3? No, 2 raised to the power 3 is not 4. 2 raised to the power 3, yes, solos. 8. Leonard, 8, good. 8. 2 raised to the power 3 is 2 times 2 times 2, which will give us 8. So that's the answer. 8. 8. Do we understand this? Okay, Nitina, is that okay? Yeah, this is 2 roots, alright? Square root, we don't need to write the 2 here. Square root, just do this, alright? If it's cube root, you write your 3 here. If it's 4th root, you write the 4. But when you just see this, you know that this is square root, okay? How do you open the bracket? Larynx. The bracket. If there was any power here, we could have multiplied. But there's no power here. This bracket is telling you that this thing here is affecting everything here. That's why we had this whole thing raised to the power of this whole thing becomes 1 over 1 over 4. Raised to the power of negative, this negative becomes 1 over, right? So 1 over everything here, which is 1 over 1 over 4. And 1 over 1 over 4 will give us 4, which is 4 over 1. 1 over 1 over 4 means 1 divided by 1 over 4. So 1 divided by 1 over 4 gave us the 4, so we could take out the bracket. So this bracket is here, telling you that this thing is affecting not just the 1, but also the 4. It's affecting everything. But now we only have one number here, so there's no need to put bracket again, okay? So we are done with that. Yeah, Annie, I just explained that. Can you explain once again? Okay, Annie. So how do you get 3 over 2? 3 over 2. That's 1 over 1 over 2 is from the question. The question says minus 1 over 1 over 2. We change this 1 over 1 over 2 to 3 over 2. How did you get minus 1? How did I get minus 1? How did I get minus 1 over 3 over 2? Shulamite, are you just joining? Do we have the 3? So let me just explain once more. So solution, this is the question. The question says 1 over 4 all raised to the power of minus 1 over 1 over 2. So we want to change this, alright? Change this to an improper fraction, okay? So you're going to have 1 over 4 all raised to the power of minus this, okay? let me leave it out of bracket first so you understand. Raised to the power of minus this, which is power of minus what? 3 over 2. Because 1 over 1 over 2 is 3 over 2. 3 over 2. Now, why is it in bracket? If you leave it like this, you want to think it's the only one that is raised to the power of this. No, it is this whole thing. So that's why it's in bracket. So this thing is affecting the 1 and it's also affecting the 4. Miguel, I'm just starting now. Where have you been? So 1 over 4 is the question. Alright, this is the question. I'm just writing out the question. I'm just writing out the question. 1 over 4. It was just for me to change this 1 over 1 over 2 here. Just change it to its proper fraction. This is it. Alright, which is 3 over 2. 2 times 1 is 2 plus 1, 3. So that's 3 over 2. So this is what we have now. So 1 over 4 inverted, because of this negative here, it will be inverted. It will be reciprocated. What does that mean? It means you are dividing 1 by this. So it becomes 1 over 1 over 4. What is 1 over 1 over 4? That is 1 divided by 1 over 4. If it's just one number, let's assume this was just 4. It will just 1 over 4, simple. But now we have 1 over 4, which is 1 over 1 over 4. So we have to change this. This becomes 1 divided by 1 over 4, which is this. And when you solve this, it becomes 1 times 1 over 4 becomes 4 over 1. Right? 1 over 4 becomes 4 over 1. When you change division to times, right? So then this gives us what? This gives us 1 times 4 over 1. And that's 4. That's 4. So this now, 1 over 4 raised to the power of minus 1 is 4. So this is 4. Now raised to the power of 3 over 2. So we are trying to take it one at a time. We've dealt with the negative power, right? So that gave us 4. Now 3 over 2. What will happen here? So this 2 at the bottom of the fraction, which is the denominator, becomes the root of 4. And this 3 becomes the power. Right? 2 becomes the root. 3 becomes the power. So you're going to have the 2 roots of 4 because of mixing, and let me write it 4, then you have 3. Now I said we don't write 2 in square root. You just do this, that's square root. Okay? But with cube root you write 3. So you have 4 and the square root of 4 raised to the power of this 3. So the next question, what is the square root of 4? You're welcome, Mike. What is the square root of 4? 2. So 2 raised to the power of 3. That's the next thing. So what is the 2 raised to the power of 3? 2 raised to the power of 3 is what? 8. That's the answer. So have we gotten it now? So let's move on, The next question. The next question says, simplify. We're going to solve like 2 questions or so more and then assignment. So simplify 16 over 81. 16 over 81 raised to the power of 1 over 4. 16 over 81 raised to the power of 1 over 4. This is simple enough for us to solve. Solve it. Let's see your answer. What will this give you? 16 over 80. Excuse me. 16 over 81 raised to the power of 1 over 4. What will be your answer? 8 from where? 8 from where? 8 from where? Litina, was that 2 raised to power 3 you are talking about? 2 raised to power 3 is 8. 2 raised to power 3 means 2 times 2 times 2. Yeah. 2 raised to power 3 means 2 times 2 times 2. 2 multiplied 3 places. That's what 2 raised to power 3 means. So 2 times 2 is 4. 4 times 2 is 8. So have we gotten our answers? Adeku should also got 2 over 3. Empty 2 over 3. Is there a video? Is there a video? Yes, Matthew. There's a video. It's recording already. Linton, I got it. Okay, good. Linton, what's your answer for this? Let's solve this. What's going to be your answer? So 16 over 81, all raised to the power of 1 over 4. What's your answer? As simple as that. Alima said 2 over 3. Oh, Alima. Okay, good. Let's see if that's the correct answer. We're going to work it out together. 2 over 3. No, not every day, Matthew. Mondays, Wednesdays, and Fridays. Mondays, Wednesdays, and Fridays. Kwasi said 1 over 2. I hope so, Alima. Okay, let's solve. Solution. So 16 over 81, all raised to the power of 1 over 4. See why it's in the bracket? That this raised to the power of 1 over 4 affects 16 and also affects 81. Now, the rule says when you have a fraction as a power, what happens? The denominator, the number down becomes the root, right? And 1 becomes your power. So what will you have? You're going to have the fourth root. This is called the fourth root of what you have, which is 16 over 81. Raised to the power of the number of which is 1. And I don't need to say raised to the power of 1. Let me write it clearly. So raised to the power of 1. I don't need to put anything raised to the power of 1. Alright, anything raised to the power of 1 will give us that same thing. Thank you, MT. So now, what's the next thing? The fourth root of 16. What's the fourth root of 16? Fourth root of 16 means, what is that number that will multiply itself, in 4 places? Is it 2 times 2 times 2 times 2 that will give me 16? Or is it 3 times 3 times 3 times 3? Is it 4 times 4 times 4 times 4? The 5, that's fourth root, okay? Now multiply itself in 4 places that will give you 16. The same thing, because this root affects both 16 and 81. That's why you see it covering all. So what is the fourth root of 16 and what's the fourth root of 81? Aisha says 2. Pastor says 1 over 3. Leonard says 4. IK 2. Emmanuel 2. Okay, the fourth root of 16 is 2. Because 2 times 2 times 2 times 2 will give us 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So the fourth root of 16 is 2. Now how about the fourth root of 81? What's the fourth root of 81? The fourth root of 81. What number multiplied 4 times will give us 81? It's 3. Fourth root of 81 is 3. 3 times 3, 9 times 3, 27. 27 times 3, 81. So, and our answer, 2 over 3. So this simplified will give us 2 over 3. Will give us 2 over 3. Any question on that? Any question? Any question on that? Okay, Larex. You're welcome, Pato. Hello, Smigo, welcome. That one machine, where have you been? You're welcome, anyway. Okay, AMT, welcome. Smigo said, Smigo, this one you're just joining. I don't know if you will understand. I get it. Okay, good. Yes, Anima, you got it. Well done. No question. Another one. Okay, we're going for another one. So the next question says, simplify. This time we're having a decimal number, 0.027. Simplify 0.027 raised to the power of minus. By the way, the YouTube channel is Learn with Austin. The YouTube channel is Learn with Austin 101. All right, or YouTube Learn with Austin 101. 0.027. Okay, I'm going to go back to that later. So 0.027 raised to the power of minus 1 over 3. 0.027 raised to the power of minus 1 over 3. 0.027 raised to the power of minus 1 over 3. We have to simplify. Okay, so when you have a decimal like this, the first thing you want to do is to change your decimal to a fraction. You want to change your decimal first to a fraction. And I think we've talked about that before. How do we change 0.027 to a fraction? Okay, let me just quickly explain that. I said anytime you have a fraction, For example, 0.5. You want to change this to a fraction, alright? So what you want to do, remove the decimal point. What are you going to have? 0.5 over any power of 10 that will correspond with the decimal places that we're having. So 0.5 over, how many decimal places do we have here? 1. Just one. That's how many numbers after the decimal point. That's what I mean by decimal places. So how many numbers after the decimal point? Just one number. So you're going to have 10 raised to the power 1, which is just 10. Just 1 0, because it's one place. If this were to be 5 4, it's going to be over 100, 2 zeros, because you have 5 and 4, okay? But we have just 5, and so it's going to be over 10. And 0.5 is the same thing as what? 5. So 0.5 is the same thing. In fraction, it is expressed as 5 over 10. Another example, if you have 0.25 and you're told to express in fraction, so remove the decimal point. What are you having? 0.25. So I don't even need to put the 0.25 because I know 0.25 is the same thing as what? 25. So that's 25 over, I have 2 decimal places. So I'm going to have 100, 2 zeros. This is 0.25 as a fraction. 25 over 100. What if you have 1.3? You want to express as a fraction. Take out the decimal point. What do you have? 13 over how many decimal places? 1. So over 0. Over 10, I mean 1 0. If it is 1.35, it becomes 135 over 100. I hope we're getting this. Zulai say I don't understand. Whenever you want to change a decimal number to a fraction, what you do first, now using 0.5 as an example, take out the decimal point. As if you are not seeing the decimal point, what do you have? 0.5, which is 5, okay? So take out the decimal point, you're going to have 5. So over any power of 10 that corresponds with the decimal place. So we have just one decimal place. Alright? We have just one number after the decimal point. So you're going to have just 10, which is 1 0. It is either going to be over 10, over 100, over 1,000, over 10,000, over 100,000, any of this, depending on how many numbers you have after the decimal point. So you are having only one number after the decimal point, so you are going to have just 10, 1 0, 5 tenths, yes. So now if you have 0.54, 0.54, so you want to change this also, alright, to fraction, the same thing. Ignore your decimal points, alright? So you're going to have 0.54. Yeah, Zulai, I hope you're following. Zulai, I hope you're following. So now you're going to have 0.54, right? Which is the same thing as 54. So you have 54 over, now 2 decimal places after the decimal point. 2 places, okay, so that will be over 100. So it's going to be 54 over 100. If you have 1.3, if you take out the decimal point, you have 1.3. What if we have 0.5? You see this 0 here? It's insignificant. You see this 0 here? It's insignificant. I can as well just say 0.5. I'm just putting 0 here just to tell you that there is no whole number. This side is for whole numbers, this side for decimal. So there is no whole number, that's why I'm just putting 0 there, just to fix in something there. So it is the same thing as 0.5. Okay, Laris. It's the same thing as 0.5. So in case you see 0.5, that's 0.5. So there's no need putting 0.5. These zeros are insignificant. Yes, you can have 0.05. Yes, 0.050, okay? But the 0 at the back is also insignificant. It's useless. So you have 0.050. This 0 here is useless. It's insignificant. And by the way, that is why I can write this. 2 naira. I can also write it as this. Instead of me writing this, I can just write it this way. Why? Because these are insignificant. Decimal place, no decimal there. Alright? So 1.3 now. So 1.3 will be what? Remove the decimal point, you have 13. So 13 over what? one decimal place and you have what? 10. So 1.3 is 13 over 10. 0.050 is, okay, that's not for me. What about, okay, 0.050 will be what? Take out your decimal point. What are you going to have? You have 0050, alright? Over how many places do you have? 3 places. So you have 3 zeros, 1000. And I said these zeros here are insignificant. So you have 50 over 1000. Are we following? 50 over 1000. And I told you that this zero at the back here is insignificant. So if we take this out, it means you're going to have 5 over 100. So did we get that? Now, let's bring it home. So what we have here is 0.027. So what we want to do is to first change this to a fraction. So what would this be now as a fraction? Somebody. What will 0.027 be as a fraction? Abdulgani says 27 over 1000. Good, that's it. So we have 0.027. So take out the decimal point, you have 0027 over 123. So you have 3 zeros, which is 1000. These are insignificant, alright? 27 over 1000. So this is 27 over 1000. So this is 27 over 1000 raised to the power of negative 1 over 3. 27 over 1000 raised to the power of negative 1 over 3. This is the question. Now, you are having a negative here, so you want to invert this, you want to reciprocate this. Just like we did in the previous one, let's deal with it one at a time. Deal with this negative and then deal with the 1 over 3. So, deal with the negative. What will happen to this? You're going to reciprocate this, alright? Please, where is the 1 coming from? Which one? No, it's part of the question. It's here. It's here. 0.027 raised to the power of minus 1 over 3. That's the question. So this one is in the question. Last time I didn't get this, but now I understand. Okay, good, Nitina, good. So now we are going to, this negative will cause this to be reciprocated, and then it becomes what? 1000 over 27. So now all raised to the power of 1 over 3. So we've dealt with the what? Negative power, the negative here. So what's the next thing? Let's deal with this now. The next rule says this denominator will cause this to be cube root. So you're going to cube root this, alright? You get the cube root of this raised to the power of 1. Are we following? So you're going to have the cube root of 1000 over 27 raised to the power of the number of 1, which is useless. It's not having any effect on it. Smigo, that's because you're just coming in. There are rules to this thing. The rules were given from the beginning. So I can't go back now. Don't worry, the video will be on YouTube. You can watch it there. So, now what's the next thing? So what's the cube root of 1000? The cube root of 1000 is 10. Cube root of 1000 means what is that number from second stage? From second stage. From here. Okay, good. Why not 1 over that? Nitina. Raised to the power of negative. Uh-oh. Okay, Smiggle, I'm explaining again. So you have this now. Alright? 27 over 1000 raised to the power of minus 1 over 3. So we want to deal with this negative first, right? What happens is that this will cause this to be turned upside down. That's what will happen. If it's just 4 raised to the power of minus 1 over 3, if it's just 4, the same thing will happen. Alright? Remember that 4 is the same thing as 4 over 1. Now, because of this negative here, this 4 is the same thing as 4 over 1. Remember, 1 over 4, where did it come from? It came from inverting this. It came from reciprocating this. 4 is the same thing as 4 over 1. I hope you know that. So when you reciprocate 4 over 1, it means you turn it upside down, and that will be what? That will be 1 over 4. You have turned it upside down. That is where that 1 over we were writing, 1 over. That's where it's coming, it came from. It comes from reciprocating an whole number. So when you reciprocate an whole number, say 2, Now you are going to have 1 over 2 because 2 was initially 2 over 1. Alright, so when you reciprocate it, like you're turning it the other, we are flipping it, alright? So 2 over 1 now becomes what? 1 over 2. 5 over 1 becomes what? 1 over 5. Thank you, Ray. Ray, thank you for the rules. Are we following? So, this now, but this already is a fraction. So, for our whole number, it's flipped over. The same thing here. It's going to be flipped over. 27 over 1,000. It's going to be flipped over. And you're going to have what? 1,000 over 27. Thank you, Williamson. Nitin, I believe I've answered that question. Smiggle, are you following? Okay, what about negative? Where it will go? The negative, when you see any number raised to the power of a negative, alright? That's why you reciprocate it. The rule says what? You reciprocate. 5 raised to the power of minus 1 means you are going to reciprocate this 5. Alright? So you are going to have 1 over 5 raised to the power of this, whatever you have here, raised to the power of 1. This minus, make this to be reciprocated. It's just like you have 1 over 5, having 1 over 5 divided, 1 over 5 divided by 3. And then you say you cannot divide this directly. You have to change this division to times. And then you have 1 over 5 now times. This 3 becomes what? Reciprocated. And you have 1 over 3. This division. So the same thing applies here. Alright, the same thing applies here. You understand that? Good. So this minus causes this to become 1 over 5. The minus causes this 5 to become what? 1 over 5. So the same thing here. This minus will cause this 27 over 1,000 to become 1,000 over 27. Thank you again, Ray, for the rules. So this will become 1,000 over 27. So you have 1,000 over 27 raised to the power of, so now we've dealt with the negative. 1 is left is the 1 over 3. 1 over 3. So the other rule says anytime you have a number, say x, any number raised to the power of a fraction, that for this fraction now, the denominator will become the root of this. The rule specifically said x raised to the power of a over b. That is, b you have as the denominator of this fraction will become the root of x. So this will become b root due to this. This 3 becomes the root of all this because you see all these are in the bracket. So this is affecting both numbers. So this 3 becomes the root of all this raised to the power of 1. So you have the root of 1,000 over 27 raised to the power of 1. And then I don't need to put the 1 there because anything raised to the power 1 will give me the same thing. Understood, Nitina? Great. So don't forget your 3. This without the 3 here, this is square root. But what we have here is 3, so it has to be cube root. So what's the next thing now? The next thing you want to ask yourself, what is the cube root of 1,000? The cube root of 1,000, what is that number that will multiply itself by itself, and it multiply itself by itself and itself again? That will multiply 3 times to give you 1,000. That is 10. 10 times 10 times 10 will give you 1,000. So you have the cube root of 1,000 to be 10 all over. What is the cube root of 27? What is that number that will be multiplied, that will multiply itself by itself and itself to give you 27? That's 3. Thank you, Oladaya. So you have 10 over 3. That is this. But we're not going to stop here. Why are we not going to stop here? I said last time when we were doing fraction that you don't leave your answer as an improper fraction. When you see a number like this is an improper fraction. Improper fraction is the one that is having the numerator greater than this. Alright? So what you want to do is to change this to a mixed fraction. Thank you. Yes. So how do we do that? 3 in 10 is 3 times, it will go in 10 3 times. Remainder 1 over this here, 3. And that's the answer. Safely. So 3 whole number 1 over 3. That's it. Do we understand this? I think we're going to stop here. I'll give us assignment. Do we understand this? At TCSC. Okay. If you have that in option, fine. You can also leave that even in your your school exams, the common entrance exam, the WAEC, if you have that in option, go ahead. You can leave it at that. Can we go to that? Any question? Yes. Any question? Any question? Thank you. Any question? Well understood. Good. No question. All right. Assignment. So, question number one says, simplify 8 whole number 2/3. I have questions. Augustine, what's your question, please? Smiggle said, I said, what if that power was 2 or 3, not 1? What if that power, if you have 2 raised to the power of, or let me use 8. If you have 8 raised to the power of 2/3, the same thing would apply. This becomes the root of this. Yeah, this becomes the root of this, and this becomes power. So this becomes root of this, and this becomes power. So you are going to have the third root of 8, that's the cube root of 8, and this one becomes the power. So I can write 2 here. So this third root of 8 is 2. 2 times 2 times 2, that's 8. So 2 now, raised to the power of 2, which is 4. Smiggle, I hope you get that. Okay, so that's what happens. So now, but if this is 1, that's why I don't write the 1. If this is 1, this is what I'll be doing. I will put 1 here, and anything raised to the power 1 is the same thing, so there's no need putting the 1. Do you understand that now? So simplify 8 whole number 2/3 times 27 raised to the power of minus 1/3 all over 64 raised to the power of 1/3. Well understood. Okay. Question number 2. Question number 2 says, also simplify 4/25 raised to the power of negative 1/2 times 2 raised to the power of 4 divided by bracket open 15/2 raised to the power of negative 2. So number 1, simplify 8 over 2/3 times 27 raised to the power of negative 1/3 all over 64 raised to the power of 1/3. Okay, that's assignment. Number 2, simplify 4/25 raised to the power of minus 1/2 times 2 raised to the power of 4 divided by 15/2 all raised to the power of minus 2. Alima, one more. One more. Number 3, let me write it here. Simplify 27 raised to the power of minus 1/3 times 64 raised to the power of minus 1/2 minus 1/2 times, it continues here, times 4 raised to the power of 1/2. So simplify this. 27 raised to the power of minus 1 over 3 times 64 raised to the power of minus 1 over 3 over 2 times 4 raised to the power of 1 over 2. So before you go, what are the rules of this problem? As people, I don't want to mention the rules again. Time is up already. Oh, thank you, Lawrence. Thank you for the finger arts. Thank you. Oh, really, Augustine? Really? Okay, 3 questions. That's it. The second is, okay, can you... Lawrence, I believe the questions are simple, right? Okay, that brings us to the end of today's class. We're going to meet again on Friday, same time, 8 p.m. West African time.